So, the last lesson in Module 8, Lesson 8.6, under linear relationships and slope, is going to be graphing linear equations. So, our learning target over here, I can interpret the slope and y-intercept of a line from an equation of the form y is equal to mx plus b in order to graph the line on the coordinate plane. Our vocabulary is going to be slope and y-intercept. We talked about this yesterday, and the y-intercept is basically where the line is crossing the y-axis or the vertical axis. Okay, so we know that the slope intercept form is y is equal to mx plus b, where m is the slope and b is the y-intercept. So we are going to use that knowledge now to find the slope and the y-intercept in an equation and then graph it. All right. So let's start with this first one that I have put up over there. It's saying y is equal to 2/3 x plus 1. So the steps that are involved in this, we are first going to find the slope and the y-intercept. Okay. So let me just bring this closer so you can see what I'm doing. All right, so if I look at this equation, we know that this over here, the 2/3, this is my slope. And then if I look at this, the plus 1, this is my y-intercept. Okay, so now that I have this knowledge, I am going to use this. And I am going to graph the y-intercept first. So what is the y-intercept? It's plus 1. So that means what is my ordered pair over there? The ordered pair is going to be 0, 1 because x is going to be 0, right? So 0, 1. So look, this is where I'm going to go, and this is my y-intercept. Okay, this is my 1 over here. So my ordered pair is 0, 1, where x is 0 and y is 1. All right. And then next, what I'm going to do is I am going to look at the slope, and looking at the slope, I'm going to locate a second point on the line. So when I am looking at this, what is my rise? My rise is 2, my run is 3. So that means I'm going to go this way. Here's my rise, 1, 2, right? And then my run is 3. So 1, 2, 3. And so this is my point. Okay. So this is going to be my point. And therefore, what is this ordered pair now? This is 3, 3. This is 3 and 3. So once I have my rise and run, that means the slope over here, I have the y-intercept. I am just going to draw a line through the points. To draw a line through the points. Okay, and that's how I graph this. So just remember again, I take the equation, I identify the slope, I identify the y-intercept. I first graph the y-intercept because that's where my line is going to cut the y-axis. And then using the slope, I am going to do the rise over run and plot another point, and then I'm just going to connect the dots. All right. So let's go ahead and look at an example here. Just to save us time, I am going to show you graphs which are drawn so that I'm not sitting and making out the entire coordinate graph, etc. But I will explain the entire process to you. Okay, so let's look at this one. It is saying graph y is equal to negative 2/3 x plus 4. So first thing, we have to identify the slope, and we have to identify the y-intercept. Okay, so if I begin with that, My slope is going to be a downward slope because it's saying negative, so it's going downwards. Okay, so we have 2 down and 3, 2 down and 3. So that's basically how we are going to go on the slope. And then my y-intercept. So this is my slope and this is my y-intercept. That means where is that line? Where is that line going to be cutting? The y-axis is going to be at positive 4. So let me show you how it will be drawn out. Okay, so let me pull this down. Okay, so here we go. And let's look at this. And over here, look, this is your 0, this is 1, 2, 3, and this is my 4. So this is where, as we said, plus 4 was your, this was your y-intercept. So therefore, that line is going to be cutting over here the y-axis at 0, 4. So my x is 0 and my y is going to be 4. So that is the point. Okay, and then I am going to use the slope, which was negative 2/3, and I am going to graph. So since it's a downward slope, what are we seeing? We are seeing it's going down to, this is the rise, 1, 2, and run is 3, 1, 2, 3. So this is the second point that we are graphing. All right, and so as you can see, this is 1, 2, 3. Okay, so this is going to be 3, 2. And this is my ordered pair. And so once I have this, I am then going to draw a line through the points to graph this equation. We're just going to extend the line through the points and extend the line, and then we get the equation like that. So let's talk about, to locate the second point, why was the slope rewritten as negative 2/3? Why did we just write it like this, like over here? Okay, and so the reason for this, the slope was rewritten so that the direction of the rise and run can easily be identified. All right, let's do another problem. Let's look at this one. So graph y is equal to negative 4x plus 5. So the first thing is identifying the slope and the y-intercept. And what is the slope in this case? It is going to be negative 4. So rise is negative 4 over run which is going to be 1. Okay, so rise over run. So we have negative 4 over 1. And then your y-intercept is going to be 5. The line is going to be cut, where it is 0, 5, which is the ordered pair on the vertical axis. So let's look at that line. Okay, and here we go. So once again, we are going to look at this. This is negative 4. That's your slope. This is your y-intercept. That means the line is going to cut the y-axis over here at 0, 5. 0 for x and 5 for y. Okay. My rise over run, which is my slope, rise over run, okay, which is my slope. My rise is how much? Negative 4 over run is going to be 1. All right. So when I am graphing this, I have 1, 2, 3, 4 this way. All right. That's a negative 4 and 1 to the right. So here is my point. All right. And then I am going to connect the dots and extend the line for me to graph this. Okay, let's do another one. And let's look at this question. All right. So a typical leopard gecko is 3 inches long at birth and grows at a rate of about 1/3 inch per week for the first few months. So, since it is 3 inches long at birth, that is going to be your y-intercept. Okay, and 1/3 inch per week, so 1/3 x plus 3. So y is equal to 1/3 x plus 3 is the equation that you are going to write to represent the length of a gecko after x weeks. When we are graphing this, all right, when we are graphing this, we are only going to have the quadrant 1 in this case. Okay, and what's the reason for that? Because the gecko cannot have a negative length and time also cannot be negative. So the line cannot extend to the left of the y-axis. The gecko will eventually reach a maximum length. So the line will not extend forever to the right either. So please remember that. Okay. So let me get this for you. And this is what I want to show you. Okay. All right. We have this. So let's look at that. Once again, what was my equation? My slope of the line was based on my equation, which was 1/3 x plus 3, right? So the slope of the line is how much? 1/3. And the y-intercept is 3. So again, drawn out. This is 0, 3. Okay, 0, 3 over here and over here. And also in the future, the gecko is not going to grow forever. So that this line is also going to stop at a certain point, okay? Because yeah, that length is going to end at a certain time. Okay, so the line cannot extend forever to the right either. Okay, let's look at this one now. And I am going to remove this so we can see what we're doing based on the graph. All right. So let's look at this. Jaden has written 6 pages of his novel. He plans to write 4 pages per week until he has completed his novel. Graph the equation y is equal to 4x plus 6. That represents the total number of pages written, y in x number of weeks. Saying 6 pages, he has written 6 pages. So that is going to be your y-intercept. So as you can see, if I go here, this is my 0, 6, x is 0, y 6, all right? And then my slope is 4. So since my slope is 4, that means rise over run. And the rise is 1, 2, 3, 4. Okay, and now if I had moved down, 2 of these is representing 1. Okay, so therefore this is going up and this is 1. Let me just show you that, because otherwise 1 is over here, so 2 of these are representing 1, so that is why this is going like this. All right, now if you choose to do 1 over here, then it would be over here, and that's fine. Okay, that's how this has been graphed. And so what's my ordered pair? It's going to be 110, right? And so then we are going to connect these 2 dots and then go upwards. All right, so let's look at this one. Graphing of horizontal lines. And when I look at this graph, it is showing me a horizontal line. So all points on a horizontal line have the same y coordinate. That's why it's horizontal, right? If everything had the same x coordinate, it would be vertical. So if it has all the same y coordinates, it's going to be a horizontal line. And you can use the slope intercept form of the line to derive the equation of a horizontal line. So what is the slope intercept form? The slope intercept form is, okay, y is equal to mx plus b, right? And so what is your slope going to be here? There's no slope. So y is equal to 0x plus b. What is anything times 0? Is going to be 0. What is 0 plus b? So y is equal to b. All right. And so therefore, the coordinates of a horizontal line can be written as y is equal to b, where b is the value of the y coordinates. B is the value of the y coordinates. All right. So as you can see over here, your y is 3. So look, all the y's, this is y, this is y, y is all going to be the same. And then, of course, your x is changing. But still, that is going to give me a horizontal line. So let's say, why does it make sense that the equation of the line is y is equal to 3 in this case? Over here. All right. So it doesn't matter, no matter what point falls on the line, the y coordinate of that point will always be equal to 3. And that's what I was trying to show you. Okay. Now, let's graph a horizontal line. And if I go here, and if I say y is equal to -1, that again means that no matter what x is, your y is always going to be your -1. Okay, so therefore the equation that I am going to write, here we go. Or do you see this? The equation is going to be y is equal to -1. And then, as you can see, it's going to be, x can be anything, but y is going to be -1. So here is that horizontal line. All right? Okay. So if I'm graphing -6, again, same thing. What is y going to be? -6. This is going to be a horizontal line again. There you go. X can be anything, but y is going to be -6, -6. And you can take any 2 points. It is going to be a horizontal line. All right? Okay. Now, let's graph vertical lines. Okay. So here is my graph of a vertical line. Really quick, before I go into vertical lines, when a line is written in the form y is equal to b, remember it's a horizontal line. And what does, the slope of the line mean, or does the line have a y-intercept? So the slope of any horizontal line is going to be what? As you can see, there is 0 slope, and the y-intercept will be where it is actually crossing. So in this case, it is what? -6. In the earlier one, it was -1. So I just wanted to quickly talk about that before I moved on over here. Okay, because the slope in that was 0. The slope in this is going to be what? Undefined, right? It's a vertical line. So now let's go into this one. So the slope of a vertical line, as I said, is undefined. You cannot use the slope intercept form to derive the equation of a vertical line because there's no slope. So all points, it is undefined. That's basically what it is. And all points on a vertical line have the same x coordinates in the graph. So no matter what y is, x is always what here? -2, -2, -2, -2, -2, as you can see. All right. So no matter what y is, x is always going to be the same. So the equation for the graph of the line, this is going to be x is equal to -2. So when I have this given to me, that means it is a vertical line and the slope is undefined. So that is why we cannot use the slope intercept form over here. And all we say, as you can see, all the x's here, this is x, 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 all the x is going to be the same value. So we can just say x is equal to -2. All right. Therefore, the equation of any vertical line can be written as x is equal to a certain value. All right. So is equal to a, where a is the value of the x coordinates. Okay. The value of the x coordinates. So this is basically how you write this. The equation of any vertical line can be written in this format. So let me show you an example. And here is one. If I'm saying graph x is equal to 4, that means x is always going to be 4. Okay. And so please look, no matter what the y values are, x values are always 4. All points are going to be 4y. That's the ordered pair. So look, okay, so 4, and it doesn't matter what y is, x is always going to be 4. So this is how you draw the line. You can graph any 2 points or 3 points or whatever number of points, but it will always be like this on that same line. Okay, x will be always 4. So when a line is written in the form x is equal to a, what kind of line is it? As we can see, it's a vertical line. And describe the slope of the line. Does the line have a y-intercept? The slope of any vertical line is undefined, and the line does not cross the y-axis. So there is no y-intercept. Okay, so there's no y-intercept because it does not cross the y-axis. Okay, and so let's do one last problem. And if I look at this, if I'm saying graph x is equal to 7, this is what it's going to look like. So it's going to be a vertical line. All right. So therefore, this is our lesson on graphing linear equations. Just by looking at the equation, you can graph it, and you're using the slope intercept form of the equation. Uh, the slope and y-intercept is being found from there, and you have, y is equal to mx plus b, where m is the slope and b is your y-intercept. So looking at that, you can do the rise and the run. And then, of course, you have the horizontal and the vertical lines that can also be um, drawn, and they are straight lines. Okay, so one does not have any slope, the other one is undefined, so they go in the horizontal or the vertical line accordingly. But then this concludes our linear relationships and slope and module 8. Have a fabulous day, everyone.